Hello and welcome to my interview with Marlin creator and lead developer Scott Lahteine. Now, it's been a couple of years since Scott and I had talked. We did an interview back in 2020, but since then a lot has been going on with Marlin Firmware. So this interview in total lasted over 3 hours. So what I've done is I've broken down that interview into more digestible pieces. I've done my best to sort of link the issues that are connected and put something special in each of the 3 parts that I've broken this down into. This video we're going to be covering the state of Marlin, new boards, new displays, some of the companies that are involved in the development of Marlin, including Prusa, Creality, Big Tree Tech, that's all in this video. And then we are going to end on the big feature coming up for Marlin, which is Input Shaper, which I know a lot of people are excited about. And there's a whole lot of other topics in this video. All of these can be found in the table of contents in the description in case even this is too much content for some of you to just watch straight through. Check out that in the description if you want to jump around. So thank you to Scott for doing this. Thanks for watching this video. Make sure that you're subscribed to this channel if you want notifications for when the next 2 parts are coming out. Now, a quick note, I want to thank Greengate 3D for sponsoring this video series. They are a fantastic filament manufacturer who specializes in PETG. Now, I heard about Greengate 3D a couple of years ago when they first started producing their materials, and they really caught my attention with the fact that their PETG is 100% recycled material, and it always will be. They are made right here in the United States, and it is a fantastic product. In fact, I have to be honest with you, they are pretty much the only PETG I buy at this point because I've had such good, consistent results with their material. In fact, back here on my board, you'll see that I've got all of my tools hanging in PETG prints that were from Greengate 3D. So again, thank you to them for sponsoring this video. I've got a little clip here that I'm going to play of their PETG being used to build a model rocket that flew to incredible heights. And so just another example of how good their filament is. So again, thanks to Greengate 3D for sponsoring this video series. Now let's get on with the interview. Here we are, October 15th, 2022, and we have with us Scott Lahteine, the creator and author of Marlin software. How you doing, Scott?
I'm doing well, thank you. How you doing, Chris?
I am doing pretty good. So I wanted to have you on because we wanted to talk about the current state of Marlin, what you've been up to the past few years, and what is coming down the pipe with Marlin, as well as, you know, just generally the state of 3D printing and anything else that we, fall into. Let's talk about where we are now. Where would you say, what would you say the state of Marlin is?
Vis-a-vis the Marlin, well, it's, it's just all, from my perspective, it's just an endless pile of things going on, constantly. New submissions, new features, fix-ups, improvements, optimizations. It's ongoing. So it's a very alive and well project. Definitely a huge amount of interest and a lot of support and contributions. I've had some really good contributions lately from a few people that are exciting. We have to keep up with all the advancements that are being made in 32-bit firmware. They that can kind of move a little quicker because it's more targeted. But we're catching up. We got things like input shaping. That's been a big deal. We're finally getting that together, which will be great. That's the cool part about that is, of course, it's all going to be, within Marlin, which means you don't have to get a new board or a second board or anything like that to support it. So you'll be able to just install it on your existing machine and tune it up, and hopefully, if your machine is tunable, you can get possibly up to like double speeds, maybe more. I don't know. I wanted to do like a bunch of demos at IRF, but I didn't have a machine. I tried to get one, but the guy who was going to loan me one, it actually died. Oh. Serendipitously.
Ouch.
So I didn't get a chance, but yeah, I wanted to run 20-minute benchies all day and show it off. But sure. I'll get. It's getting better now. I'm not even sure that during that last week that it was completely perfect yet. So it's gotten better. So hopefully I'll have the ability to do that real soon.
Let's talk about before we get what's coming. Let's talk about what do you think have been the biggest advancements, or just even the slow progress that we've had in the past 2 years of Marlin since, like you said, since you've been hunkered down. What to you stands out in your mind as the biggest advancements that we've had?
Let's see. Well, we fixed up ARCs, which had a few issues. It wasn't perfect. So G2, G3 got a lot more attention especially when like the ARC Welder plugin came out for Octoprint. Then suddenly, all kinds of G2, G3s were being thrown at Marlin, and a few quirky edge cases were causing issues. So we also got that optimized. Our contributor Tom Brazier has been really hitting it hard and putting together optimizations here and there. And with that particular one, once you know the angle of the curve, you can just say, oh, well, we can go this fast. And we just have to pass the angle on. So so that got optimized because previously it was just looking at it as little segments and treating it like little segments. And because they're little, the look ahead wasn't great.
Right.
So it was like, well, we can substitute look ahead by we already know the information, so we'll pass it on. So that's one good optimization, and so some bugs were fixed there.
Let me go and pause there, because I have played with Arc Welder, and
Yep.
I find, if you're on a reasonably fast modern board, you don't see any differences between an arced print and a line segment print. So,
right.
I mean, do you think that, like, is there going to be a reason to use arcs, or if I have a fast enough machine, is it just pick one?
Well, I mean, you have an option. Like if you're using, say, an older, slower AVR board, arcs, and you're using, say, a slower baud rate, like 115K, because you don't trust 250 or something. And some machines are actually built with that and shipped that way. So you want to, you can get those. You could boost it up to 250 and get better rates. Or if you're using USB, you'll have the fastest speed you can. But many, many, many small segments actually causes something called planar starvation. And so if you want fine-looking surfaces, and that means you have to either slice so you have lots of very small segments, which risks planar starvation and also makes the balloon in size. Or you can set it to use longer segments on your arcs, which then gives you a smaller G code, fewer segments, but the segments are longer, and so you have a rougher looking surface with more facets. Or you can set it to use G2, G3, in which case you get one command and you get a nice smooth arc. So, obviously G2, G3 is your best option. And Arc Welder, if you're going to use it, you should set your slicer to use bigger segments, because it'll make the Arc Welder more efficient. It'll still see the arcs that are there.
Oh, okay. That's good to know.
But it'll be gathering them from longer segments.
Okay.
So if you set those segments to 2 millimeters even, it would be oh, well, the thing is maybe 3.5 millimeters long in your curve or something.
Right.
One of them will be 2, and another one will be the remaining part or whatever. But so I'd say, you want to go at least maybe 1 millimeter or something like that. But in general, G2, G3 is always going to be better, especially for smaller boards.
Okay.
And then in general, if you have faster boards, G2, G3 is going to produce the even smoother arcs. So it's the faster your board is, the smoother your stuff's going to look. So
okay.
There's that.
So in general, using the arcs is always a better method. It reduces G code size. You get better looking arcs, and it's going to work better on the slower hardware.
Absolutely. And the cool thing about Arc Welder,
as I think you said, it's even working better on faster hardware.
Absolutely. I mean, faster hardware, if you did that slice with the bigger segments, you're going to get the same result, whether it's fast hardware or slow hardware.
Okay.
Maybe your corners will be a little tighter or something, but in general, yeah. So your facets will be more facety. But yeah, what you really want is to get those smooth arcs, and even on a slower AVR board, those arcs are going to be nice and smooth, and you can set them to be as smooth as you need. So that's the main advantage of that for sure. Yeah.
What else have we added? recently, and recently being 2 years or so of Marlin.
Yeah, well, of course, the big thing, of course, is just lots of boards, lots of displays, TFT displays, and things like that. So, basically, it's like all the boards.
Right. Yeah.
We're trying to get as
basically the motto of 2.2 for all the boards, right?
Yeah, and I have to admit, like, we haven't really tackled the Duet 3D boards, like the bigger ones.
Mm-hmm.
And part of that is just, I actually feel like it would be a disservice not to use RepRap firmware on those boards because it's so well adapted to them.
Right. It's what they've been designed for.
Yeah, it's kind of like, I'm happy to take like an E3D tool changer and put a Octopus board in it, for example, and run Marlin on that because it's made to do that. But if there's a Duet board on there, I'm just going to run RepRap firmware. But, if someone in the future decides, hey, let's get the Duet boards, Wi-Fi and all that supported in Marlin, that would be awesome. Just because, why not? Maybe you have an extra one lying around, you want to do something special with it, but you don't want all the RepRap firmware, like extras or whatever. Marlin is nice and, in that you can just compactly install it on there and get it tailored or whatever. So that's pretty cool. We got support for 9 axes now, like linear or rotational axes. So things like the, if you were at ERF and you saw like that 5th axis cool thing that was there, well, you just ERF, but if you've watched any videos about it, there was like Duet 3D was showing off a 5th axis thingy that's like, you just basically tie it down to your bed of your machine and or hook it up to the rails or whatever, and it has a little extra tilt on it. And there's slicing that is specially tailored for that. And you can actually download all the files for it and build one yourself. And all you really need is a stepper motor attached.
It sounds to me it's one of those things that probably the slicer was a bigger problem than the firmware.
Yeah, I'm glad
because we have all kinds of firmware already that can control stepper motors. You put the stepper motor wherever you want to, and then you just need a slicer that knows how to interpret where that motor is and what's it doing.
Absolutely. In a sense, like every type of machine you might make kind of requires its own little niche in the slicer world.
Right.
So if you like a polar graph like robot, which is like a plotter that does it by hanging or whatever, hanging plotter, one of those types, which also is in Marlin now. If you have one of those, then you're going to be using its kinematics, and so you need a slicer that can output the G code, which is still the same kind of G code, but it's just tailored to these kinematics. And in general, you want to say just as much as possible, you want to say X, Y, Z. That's just send that information.
Mm-hmm.
But if you have a special axis, like on say a hang printer or on this 5th axis bot, or I don't think of anything else that has an extra axis on it. It's nice to have that you're either going to have a slicer that outputs that as another axis, or you're going to have one that outputs just X, Y, Z, and then you have to have kinematics tailored for that new axis. In our case, I believe the 5th axis is actually output in G code as like maybe a U axis or something like that. I'm not sure, but
the idea that G code for that printer will run correctly, but if you shove that into another printer, you wouldn't do something horrible.
Yeah, it doesn't have a 5th axis, then it's just going to ignore that
exactly.
5th axis code. So, and you'll get whatever you get,
right.
Probably spaghetti. Yeah. But yeah, so the cool thing is Marlin already has that. So when I was looking at that, I was like, oh, this is really cool. Duet 3D showing this off, and I was like, I wanted to jump up and down and be like, this will work with Marlin too. Right now, just give me the G code and give me this device. So I'm actually gonna get all the files and build one, and I've got plenty of spare steppers, so I think it'll be fun. And then we'll maybe formally adopt it like we did with Belt Printer, for example.
Right.
If you enable Belt Printer in Marlin, now you have like special commands like the repeat code, so you can just keep printing things endlessly.
Yeah,
and,
I like that.
Stuff like that.
Yeah.
M808. Yeah, named after the looping machine that all the kids used back in the day.
Mm-hmm.
The Roland 808, I think it was. Yeah, so obscure, but we had to come up with some number. So yeah, that's pretty cool. We also put in, let's see, other cool things. Model predictive temperature control. That's an alternative to using PID tuning on your hot end.
Is that that auto temp feature?
No, it's not quite. It's like PID. in the sense that it tries to keep the temperature stable on your hot end and reach it quickly and try not to overshoot too much and all that kind of stuff.
But it's active rather than being PID, which is preset?
Well, they're all active. PID is like it adjusts to the parameters you give it, but it doesn't change its parameters as it's running.
Right.
Although you can create PID loops that are smarter and like adjust themselves if they see themselves getting too wobbly.
Yeah, that's what I was wondering. Yeah.
Yeah, it can attenuate or whatever. This is similar, except it's based on a physical model of the hot end.
Okay.
You tell it basically how many watts of heat can it retain, how long does it retain that heat, and that kind of thing. And it basically, using that model, it provides an extraordinarily stable temperature, even better than PID. Although if you've got really well-tuned PID, it's good. But this seems to be even better. The overshoot is typically smaller, and the stabilization is typically quicker. So it's a really...
How much technical information, though, given what you just said, how much technical information do you have to have in order to give the model what it needs?
Not too much. There's some examples, so you can kind of pick one that fits your hot end.
Okay.
And you may have to tweak it a little bit, but in general, it's pretty easy to tune.
Okay.
It's not more difficult than PID tuning, although we have like the automatic PID tuning.
Yeah.
I can't remember if we have exactly that for MPC at the moment, but I think we can certainly get that worked out if it needs to be. But I definitely encourage people to give it a try as an alternative to PID, especially if you have like things like your fan comes on and it causes the temperature to destabilize and stuff like that. This actually is able to notice that and deal with it, so it should prevent things like strange thermal runaways that might occur with PID because PID is typically tuned to a very specific environment, and if the environment changes, PID can get a little screwed, whereas MPC is a little more robust against that.
Okay. And I assume that those are settings that can be changed, like if you were distributing binary firmware, those are settings that can be changed once the person has it for whatever hot end they've installed.
Yeah, there's menu items to change those parameters.
Okay.
And G-code as well. The actual G-code itself, well, your viewers don't have to memorize it. You can look just go to the Marlin Firmware website and type in MPC, and it'll pop up in the search results. And the G-code will be there as one of the search results.
All right, I'm definitely going to have to try that one as maybe one of my weekend excursions.
Yeah, it's more of like a half a weekend. I'd say spend half your weekend on that, and then half your weekend on input sheet. That'll be fun.
Absolutely.
That'll be a good weekend.
Let's circle back to board support real quick, because sure. I know there's a lot, I don't know, you could call it a lot of companies at this point putting out boards, and there's definitely a few major players putting out a lot of boards. So how much support in any companies you'd like to mention that are particularly either supporting Marlin and supporting you personally, and that are feeding back into Marlin? Who do you consider the companies that are really playing well with you and playing well with the software?
Yeah, we've had a lot of support over this the last few years from MakerBase, from Big Tree Tech, /BQ. Had a little bit of interaction with Prusa, although they've been very much focused on their own firmware. Maybe working with them more closely to make sure there's more cross-pollination between our firmware projects.
Sure.
And more stuff coming upstream from them, which would be great. Let's see, some others, if I quickly peek in my pile of Discord messages who I've been talking to.
Sure.
Let's see. There are as far as board makers go, it has been mostly Big Tree Tech has been really there all along, and it provided some test equipment for us. And they've been working on some other things like Panda Pi.
Oh, good. Also, yeah, I've heard from them.
That's sort of more focused on Clipper. Mm-hmm. We do hope to get something Clipper-like, as it were. We already have Marlin running under Linux, so the boards that are now running Linux on one side with, say, an STM32 or some other chip on the other side, where to combine, Clipper with the clipper or hand, the clipper stepper or whatever you want to call it.
Sure.
We have something like that in Marlin already, so we're going to be looking at being able to run those boards and take advantage of that extra power in some ways.
But with companies such as Big Tree Tech, they're doing a good job of feeding back into the Marlin process, giving you their code, making sure they're complying with the licensing, the GPL.
Yep.
These folks are in good standing, and that's kind of what I wanted to talk about.
Yeah, MakerBase, again, also very, very, very helpful. We have like MKS Sean is one of our regular contributors and some others.
Fantastic.
I would like to say, let's see, I've gotten some stuff from Trinamic directly.
Oh, good.
Testers and things like that, which were super helpful. And as far as companies that support Marlin and fund its development, well, Prusa's there, and Lulzbot as well. And they've been with us for probably from the beginning, although there was a brief break, as you can imagine, during their restructuring.
Sure.
But they're back.
Good to hear that. I'm glad to hear that.
They're back.
So I am curious. I'm curious what the relationship is with Prusa. I mean, I assume at the beginning, Prusa was simply using Marlin. Let's go back, far enough where they were just using Marlin as is and producing a printer based on Marlin. Then they would start making a few changes from a software perspective that would differentiate their UI or their feature set a little bit. And then they went, of course, into making boards, making bigger software changes. And how much are they running Marlin or as opposed to a fork of Marlin? And then how much are they feeding that back in? What is what are they doing currently, and then what are they going to be doing in the future, as far as you know?
Yeah. Well, originally, I mean, their machines were based on like Marlin 119 or something along those lines, and from that point, they forked it. They kind of stripped out all the stuff they didn't need, Delta and all that, and produced a nice optimized, like concise version that's specifically targeted to their machine. Later and more recently, they've been adapting Marlin 2 point something, which has all the reorganization, the various HALs version boards, and I imagine I haven't looked at what their current version looks like too closely. Been letting them elaborate and work on it, things that they had to fix, things like linear advance and stuff that they fixed a bit early on. We finally got some of those fixes over.
Is Prusa software, is it still a fork of Marlin, and is it still open source?
It will be, and actually there will be more. There's something more cross-pollination between Marlin and Prusa Firmware coming up. We had a good meeting at IRF and talked about that, and it sounds like we really want to do more sharing back to the open source community in Marlin, and that's kind of been. I feel like Joe actually feels a little bad about the fact that it hasn't been pushed upstream, and wants to get more upstream for the open source community. Because that's where we started out, man.
I mean, up until this point, I haven't been a consumer of Prusa printers. I don't own one. I do have my pre-order in for their big printer, because that finally entered my wheelhouse of things I thought I needed. So I'm looking forward to consuming their machines, but I am a big supporter of open source software, and I do want to know that they're contributing back to the process in the way that I would hope that they would.
Yeah, and I mean, they're always devoted to open source, and it's just a matter of having things be mature. There is they've also got a firmware called Buddy, which is for their like what does it call it? The other type of 3D printer, the ones with the light.
Oh.
Is it a DLP or an SLS? I can't remember. SLA.
Yeah, the SLA.
Digital light projector, I think, right?
Yeah, I mean, theirs works the same as everybody else. It has a LCD display in the bottom, and
and that's a whole different ball of wax. But yeah, all the stuff that they've been doing, like with their like Prusa Mini and stuff. I love that firmware. I love that it's the UI on that display and stuff. It's really nice. Really well polished. I'm trying to work towards that. Generally speaking, they're not like the companies that sent. Almost nobody really does a whole lot of contribution back upstream, which is interesting. Like companies will make a fork and then they'll make a bunch of changes, and then it'll be mentioned or someone will bring those along, but it isn't often the actual company themselves. I believe that's like, in a way, I can sort of understand, like that would be an extra time that someone would have to spend, which doesn't necessarily go towards their company itself, just goes back upstream to everybody.
Right. I mean, yeah.
So yeah.
And I guess there's two ways you can look at that. Number one, it's good to give back to the community, but number two, obviously, your quote unquote competitors are also going to have all of the stuff that you've worked on if you've put it back in mainline.
Yeah, and I could say, like, I could spend all day doing nothing but looking for forks that support machines or boards or obscure things that we don't quite have ready yet. Like I just found, for example, TAS 6. We somehow never got a config for TAS 6 into our pile. So I just happened to find one based on like an old 102 or something like that. And I was like, okay, well, I can work with this and sort of adapt it. But yeah, it's a lot of sort of hunting and finding things and then bringing them in as time allows, while also trying to like keep up with the newer stuff coming in. So yeah, it's like the newer stuff tends to not leave a lot of time to go sleuthing after that. But I'm always like hoping and that people will bring that to us. And like, for example, the stuff that Tiny Machines has done for their boards has they've had that been working on that stuff for years, and yet it hasn't really been full. A lot of it does come upstream, which is great, like things like the tool changing fixes and things like that, dual X axis and stuff like, or I should say dual X carriage or IDEX. A lot of that work has come back to us through Insanity Automation, also known as David, or the other way around.
It sounds like to me the stuff that might end up back in Marlin is probably the stuff they don't want to have to keep patching.
Yeah, pretty much.
I mean, not just for Tiny Machines, but for any company.
That's you should put that out there. If you want to keep patching it for every version,
Yeah, I mean, there's something to be said for if you give it to us now, then you don't have to keep backporting all your patches.
Yeah, I mean, it is like you're investing a little time now to save time later.
Exactly.
It's an old trick that I hope more will take advantage of, because we could certainly use more of those contributions of like obscure things or just boards that aren't there. And I almost take for granted that I forgot to mention, of course, Creality has actually been super supportive as well.
Oh, that's great.
Initially, I had Naomi Wu as a liaison, but she has since moved on to greener pastures. So I haven't really had a lot of direct communication with them, and I believe they're focusing on some different kinds of things, so they haven't paid as much attention to Marlin lately. But they do continue to help us out, and whenever if possible, like for example, the belt printer was like, that was direct collaboration between me and Creality, and they got a little extra support out of that, and a machine, which I'll probably hang on a wall, because that's what you do with them.
Because that's what you do with them now.
Yeah, and so that's a fun thing to play with. I haven't printed any swords yet, so I feel kind of like it's another thing I got to do with that. But yeah, so they've been another one that's been really helpful, and of course their boards are they put out a lot. So and then they put out machines where board variants that you're not sure what they are necessarily until you open them up. And
right.
Oh, this is a revision 14. So yeah, we sometimes have to find out about them that way. But in general, they have been fairly easy to support, and they do delay a little bit in putting out their versions of firmware, but they always end up doing so. So
I was going to ask, I mean, because they do seem to get some flack on Twitter for day one not having a configuration available when someone contacts them. I mean, do you personally, given that it's your software project and you're the holder of this GPL license, do you see that as a big deal, or as long as they get around to it, you're pretty much okay with it?
Yeah, I mean, in a sense, you kind of have to be tolerant. There aren't. I mean, as far as defending the GPL, there are different options that you have, but some they can be pretty draconian. The main advice you get from say the Free Software Foundation is just negotiate, talk, communicate, and then work it out first. If you can't, then there are other remedies. But in general, I've never had to. Only in the distant past did I have to apply a remedy, because it seemed like there was a long delay going on, and then there was this misunderstanding where someone misheard something that one of the representatives, Naomi, said, which was, she had said something to the effect of, they're never going to put out the firmware
Right.
source, but it was followed by if blah blah blah, and the person kind of missed the if part,
Right.
and so they reported it to me as, hey, I heard Creality just said they're never going to put it out, and I was like, they're never going to put it out, and shame on them, I will shame them. But yeah, it was just a misunderstanding. As it turned out, a third-hand game of telephone that it was all worked out actually within hours, really. So yeah, that was a fun time. But in general, yeah, there was a little paranoia because we felt that, well, they're way off in China and they've got a whole different culture and maybe they don't respect copyright and all this other stuff. But it really comes down to is just, the logistics of getting everything together, finally putting out a firmware on the website and all this other stuff, having it be the right one and so forth. And, I'd love it if they just included it on the SD card when they send you the printer, but, it's a big pile of files.
And I do wonder sometimes, anyone that's ever dealt with software distribution, releasing something, like I'm working on a big code base of software that's mine right now. And there's a big difference, at least for me, between going, it works, I can use it, and I'm willing to give it to someone else.
Right, yeah.
And I'm sure you do that too. We all have a tendency of writing code the first time, and that's to get it to work. And maybe even a configuration file for Marlin might be, well, this works and we're okay with how it functions, but that doesn't mean we want to give it away yet, because it may not be production in terms of like showy-offy.
Yeah, and to a certain extent, it's like maybe you do want to put it out because the idea of open source is, well, someone will see your bug and fix it and then tell you and give it to everybody else. That's the theory. And in general, we do get a lot of, so much of our fixes do come through users who are just saying, oh, I tuned my config and this is better. And
Right.
that side actually turns out to be this and blah, blah. So yeah, there's a lot of little fixes we get that way. Very oftentimes, we'll get stuff from, say, Big Tree Tech, and it takes 3 or 4 tries before everything is supporting the board just right, even getting this pin correct and that function on that correct, and just because there's an awful lot of moving parts with any of these things.
So what else have you been working on lately?
Well, not super lately, but we have been doing a lot of laser improvements. And I guess if we haven't been doing it lately, they must be pretty stable, right?
When did those laser improvements get in?
Oh, geez, let's see. They've been doing a lot over the last couple of years since early 2020.
Right.
So, just like little bits here and there, things like, moving power control into the stepper routine so it can switch power more quickly and get finer details and stuff. And so, yeah, we've got a lot of that going on.
Do the lasers use something similar to PID for?
Well, it's a PWM device, right?
Okay,
so
I got you.
So you can only switch the laser power as fast as some period of your PWM cycle. We had a K40, so we were able to practice with that, and it was a lot of fun. And then later, more new improvements came even after we got rid of the K40.
And there's a ton of new laser machines on the market, and I know firsthand because I'm asked to review every one of them, and I turn almost all of them down because they're all basically the same. It's almost the same thing you can say about how many things these days are just Bedslinger clones. Are most of those running Marlin, or are they running something else? Do you know what they're running?
I know they don't probably no lasers are coming with Marlin.
Okay. I haven't looked into what software they're running internally.
Yeah, I'll have to. I wish I had more documentation of photos and videos about of the laser as it was being developed. Mm-hmm. Most of that was happening I'm over here working on Marlin, and Lou was over in the other room working on the laser stuff, and then I would see what got lasered, and I would be like, that looks great, so it must be working now. So it'd be cool to get more details on that and have a nice tutorial out there or something on converting your K40 to run Marlin. Okay. Because with that you get so many nice improvements, like the full menu, and you can put your better screen on there. You can use some, obscure board, some board that you had as a spare, and get rid of that tiny laser board that usually isn't that great anyway.
I mean, one thing I noticed with the couple of lasers that I've played with is that they're not as user-friendly as a 3D printer, typically.
Right, they come with those membrane keys and stuff, and that like a tiny display, and it's like you'd much rather have like a full Marlin display on it. So yeah, we've got the whole thing where it's got like the laser icon on there next to the fan, and and all the other things. It even shows your XY's.
Well, and I mean, I think to answer my question, some of them don't even have anything other than very basic movement software, because they actually want you to hook up over USB and control it all from your PC, rather than having some sort of internal memory that's going to print your laser. Yeah,
I mean, I imagine they must have they have software on there, maybe it's laser burn or something along those lines, which is more, which basically has the ability to, do lasing and turn the power on and off real quick in the way that we now
seems to be just very CNC software. It's not a full suite of control, really, that's built into the device.
And that's the thing. Everything that applies to laser also applies to the spindle in Marlin. So it's like, you can switch to one to the other. We don't have like the option to say, oh, I have a machine that has a spindle and a laser and a hot end, and I'm going to switch between them. But that could come. That's like there's some G codes for that kind of thing.
Well, with lasering become more advanced. I mean, we see lasers now that are coming with extra axis control, like for printing on cans or bottles or whatever,
Yeah, absolutely. And now that we have that multi-axis support, it's like that it opens up the possibility. In that case, I guess you treat it as a rotational axis. And that's one off, rather than a linear axis. And you throw an end stop on there or whatever, and that kind of thing. Well, I want to say that CNC is generally improving. Like there's things like a G0 rate and other things like that have been added. There's like drilling cycles are sort of in the works. But little by little, it's becoming more friendly for CNC, which is maybe, I don't know, maybe it's off mission. But heck, we're throwing everything else in there, so why not, get as much CNC in.
Well, I mean, and as we talk about all of these things, CNC, lasers, 3D printers, they're all motion control systems, and anything that we can co-opt from one to the other makes that other software more powerful. So having these all kind of integrated in some ways is a plus for all of them.
Absolutely. I think to some degree it's just a matter of like, well, I've got these extra boards and I want to use them for whatever, and if I can put the Marlin on there and then use it in my project, like like for example the Lumen pick and place, for example, that's there's another machine that Marlin supports. As long as we're listing those, besides that belt printer, foam cutter, that's another one that's in there thanks to the extra axes. I mean, all kinds of things become possible, right?
I think the second that someone starts playing with the 3D printer, maybe builds a 3D printer from scratch, from a kit, start to really understand that it's just a motion system, that there's no magic here. It's just how do all of these things interact to produce something. Then your brain starts getting going about, well, what other things can be done with a motion system.
Yeah, I mean, the smart stuff comes in when, like, you want to just be able to command the machine and have it obey, like, everything. As much as possible, have it be kind of dumb. But on the other hand, when you do a move, you want it to start out slow and ramp up and then slow back down so you don't get this, you don't lose steps and get jerky motion. So there has to be some smarts in there.
But again, all of that smarts is good to share. Like, a CNC needs to do that just as much as a 3D printer needs to do that kind of thing.
Absolutely. Yeah, and typically I find, like, of course, if they're using smart servos, they can get much smoother motion, faster, stuff, and more intelligence in there. And if you're spending, the big bucks for a big CNC, you might as well, get the best motion control you can. But yeah, I mean, that's the great thing about Marlin is you could use it for, whatever, a big old thing dropping cement to build a house, or you could use it for a big old CNC or a hang printer or many other things, but, and the sky's the limit when you've got like 9 axes and up to 8 extruders and, several heaters, as many heaters as you can attach, and as many temp sensors as you can attach, and other things like that. it all comes, together, and you just say, okay, I want to coordinate that. Move there, heat up. Move over there, heat, cool down. Turn on the fan.
Yep.
Turn on the laser. Bring in the robot arm. Whatever else you have, that all you can now start to coordinate all those and build, crazier machines, whatever you have in mind.
I guess the one thing we have to worry about though is that if more and more things start using Marlin, then we're going to have to clone you more to be able to put all of this new features in there.
Yeah,
I don't know how you would handle the amount of bandwidth if you started getting not only 3D printers but CNCs and lasers and.
Yeah, I mean, I'm pretty snappy when it comes to getting through stuff, but as far as the editing of text and so forth, it's sometimes a little too quick. I have to stop myself to slow down so I don't leave bugs and typos.
Right. Yeah.
Yeah, it's yeah. I mean, we certainly have a lot on deck, and it's I certainly personally can't review and test everything. So it's the more testers and stuff we have on the side, the more that helps.
Right. I mean,
the Discord for that. So.
And as a creator, that has to be very difficult. I mean, I deal with that. I mean, any of us that have ever done embedded software development, we're used to having to test everything ourselves. But when you start doing an open source project where you're not going to have access to all of the hardware, you can't test it all. You have to start taking people's word that what you are going to commit does what it says it's going to do, beyond what you can read in the code, obviously.
Yeah, and I have a lot of fun sleuthing with people, when guiding them to help us find the answer is always fun, because basically my approach is simply to say, oh, well, try this, try that, and then after they try it, I go, okay, that's a clue, and I can narrow it down pretty quickly with just a few suggestions, and that seems to work best. And I try, and my aim is to as soon as I encounter some bug report, I want to get it fixed as quickly as possible. So rather than ask for a bunch of arbitrary information from the user, oh, give me a log and give me that, if I can immediately first just go and look at the code and say, oh, there's an obvious typo. Okay, great.
Yeah.
But if it requires a little more, we'll go through it as quickly as possible, because the quicker you knock down that one foe, the less that foe is going to be knocking you down in the future. So
absolutely, yeah.
Yeah, so we'll knock it down quickly. So yeah, it's a fun process, but it can be tricky. It's you're definitely looking through a glass darkly to try and find these things sometimes.
So that's where we've been. That's what we've been working on the past few years. Obviously, short term, the biggest, most exciting thing is the idea of doing input shaping, which we've got. Apparently, from hearing from you, it's probably what you hear about more than you care to talk about. But it's there now, and you're testing it.
Yeah, I mean, there's it's the killer feature these days, right? Because that was kind of what sold Clipper a lot, was the fact that apart from the fact, you get some smooth motion with it. That's you can get smooth motion on a 32-bit board, a relatively inexpensive one these days. They're fast.
Right.
They're basically your base level 32-bit board right now is 10 times to 30 times faster than your basic AVR printer board.
Sure.
So that means you can print 30 times as fast? No, you can't print 30 times.
It's basic math. 30 times faster processor, 30 times faster printing.
You would hope, but you can do a lot more, math or processing and look ahead and heuristics and other fancy tricks, and use that extra processing power to improve your results. And one of the things that's been a big deal has been getting rid of those ugly little artifacts that show up on the surface of your print from your printer vibrating. Mm-hmm. And that's called input shaping, or resonance cancellation, or compensation.
The stuff that we've thus far been tuning manually with acceleration and jerk settings and
and just tightening your machine with some screwdrivers and welding parts together, whatever you have to do to just make it more rigid.
Now, I want it metal, not plastic, because that helps all of these things. But with input shaping, it opens us up. It makes things not have to be as tuned and as rigid, and because now we're going to do testing and sensing, and we're going to find the sweet spot.
Yeah, I mean, it's an acceptance of the fact that you're dealing with a physical system that is going to ring, that's going to vibrate, and you can't eliminate every bit of the vibration physically unless you basically wrap the whole thing in concrete or something. I mean, it's
Or just slow down to the point of it's not moving fast enough to actually vibrate.
right. And you saw like Chris, if you might have seen Chris Riley's video where he tried various things using sand and putting it on a carpet square on top of a brick. And that I think his best results was just using a square of carpet on a big old slab of stone. And that got rid of most of the surface artifacts because that vibration was being dissipated very quickly. And so what
I
you
think
want
CNC Kitchen did those tests as well, right? Did Chris and CNC do them?
Yeah, I may be mixing those up. I know Chris
Okay.
did some, and probably and CNC Kitchen also did some, and Tom
Okay.
also has done that kind of thing as well.
Mm-hmm.
And yeah, so there are various approaches you can take physically, but you have eventually you have to deal with the fact the remaining residual ringing, whatever it might be. And the theory is that anytime you create motion, you're creating sort of an opposite effect in the frame itself. So when you slam your X carriage to the right, it's creating a force that's pushing to the left from the very first step. And as soon as it pushes to the left, it's not like your machine's going to tip over. Instead, what it does is it just swings back and forth, and it swings back and forth very quickly. And we call it ringing because it's in a range of around between like 10 and 30 hertz in that range.
Mm-hmm.
It's low. It's low frequency. It's not like really, really high frequency, although there can be harmonics in there. And so the tuning is really just a matter of like, anytime there's a kick this way, you want to catch it as it's swinging back and create a kick in the same direction. But as the machine is swinging back doing that, it actually causes it to dampen, which is a pretty cool trick. So if you're
Yeah, and I was going to say, I mean, right off frame here is the first clipper printer I've ever actually played with. I haven't actually had the time in my schedule to play with a clipper-based printer. Big Tree Tech is now, by Q, is now producing one, so I got their sitting here. And so this was my first time of doing that resonance tuning on a printer. And I did find it extremely interesting watching it go through the frequencies, and you don't see the printer moving, but you feel the movement in the table. So the precision of those 32-bit controllers and the precision of the stepper motors to be able to generate all of those frequencies from 1 hertz to, I think they go up to like 130 hertz is pretty fascinating to me. That it's able to, because you can hear and feel the difference as you're stepping up through the process.
Yeah, I mean, have you ever used a printer with like 8x microstepping or something like that, where it's like really low, or you can go down to 1x microstepping if you really want,
right?
And it's just like every step creates this jerk because it's doing this quick jump, right. And we got trinamic steppers now, which do this cool interpolation. So you're taking a 16th of a step or whatever, and it's being smoothed out by 60 more little steps that you never get to see.
And that's all being done in hardware, so luckily you don't have to do all those calculations.
Yeah, and the fact that it's quieter is indicative of the fact that it's not creating as much vibration and ringing in the frame of your machine.
Right.
And so that, but the frequencies are interesting. Like, it's so the cool part is that all you have to do is just time your. It sounds simple. The theory is simple. You just have to time these steps so that they happen at just the right time to create cancellation. And there are various ways to approach it. And the clever coder we have, it's this guy Tom. Tom Brazier is like
more Toms.
He's the guy. He's the man. He brought us the MPC temp, and then figured out an approach to just create a very simplified input shaping that's kind of bolted into what we already have, and doesn't know anything about your acceleration. Doesn't know much about any of the higher level stuff. It's all done at the step level. It's just done through taking for every step that you're going to generate, you want to create an anti-step, so to speak, and that's all a matter of putting it at the right time. But the thing is, you can't just throw more steps in because you'll go twice as far.
How is Marlin tackling what we've been talking about versus how Clipper been tackling it thus far?
Well, I haven't looked very closely at what Clipper or RepRap Firmware do, in part because their code is like, there's a lot going on, and to decipher it is like tricky.
Okay.
You have to go to this file and then follow it where it went, and then follow this and see it. And so it's not all, but there is a lot of, there's a great commentary in those source codes describing the theory, and there's a lot of papers on the theory.
Okay.
And different approaches to it. There are other types of things. There's a filtered B-spline type approach, which is similar kind of concept. It changes what would normally be a regular acceleration, which is like linear acceleration, and changes into a more S-shaped acceleration. But the S-shape is tuned in a way that it fits it. It's connected to the resonance of your machine, and it actually can be more generalized, so that you don't necessarily worry with that particular theory of cancellation.
So is there not really a direct comparison to how you're doing it versus how they're doing it, just from the standpoint of they implemented theirs, you implemented yours, they were kind of built up separately from the ground up?
Yeah, I mean, we had to adapt it to what we had. It was either going to be rewrite what we had using a new methodology, maybe what's called a time-based stepping. What we do have, what is essentially at a dynamic level, is time-based, because we're saying, oh, we want to do the next step at X time, and so everything is calculated out pretty precisely.
A lot of timing stuff going on in the code with when you're doing what.
Well, in terms of, like, you've made a step, and now you need to see when does the next step got to be. So we leave our interrupts there, which takes care of that. We go back to doing the main loop. Okay. And then it'll interrupt again to do another step. Okay. And so, that happens, we're talking 20,000, 40,000 times a second at the highest rates, depending on your, stepper situation.
And let's be clear while you're mentioning it.
Yeah.
This is all perfectly doable in the existing hardware. You don't need that Linux sideboard in order to do this level of calculations.
Yeah, no, I mean, it depends on your approach. I mean, I was very surprised at how small the code that's added by Tom was. It's really concise, and it's naive and crude in a way.
It's elegant. Let's use the word elegant.
Nevertheless, it works. And all it does really is, like, it takes what would normally be motion that is, step, 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 and it just divides it in half, step, step, step. It creates that part, creates this bit, and then takes a copy of that and overlaps it. Okay. So if your machine is vibrating at whatever half period is 10 milliseconds, it'll start the next one at 10 milliseconds. So you can imagine the motion will start out at half speed. 10 milliseconds later, it'll suddenly double, or begin to, at least the acceleration period will start to double, as it were. But yeah, your steps are actually being interleaved in such a way that for every step here, you're getting one 10 milliseconds later here. Mm-hmm. So that as your machine is doing that swing back that it was started here, it should be hitting it here. And
the idea of countering idea of countering the resonance as you're going, rather than, I don't know, making sure that you're not causing it. You're always compensating.
Yeah, and that input shaping is, again, it's a surrender to the fact that you do create resonance, and so all you're really trying to do is just create anti-resonance. It's like noise cancellation. It's the same idea. You take a signal and you create an opposite signal, but in this case, you're using time instead of like amplitude. Like if you had a sine wave, you would take an upside down sine wave and overlap it, and suddenly they're canceled. You get a big long flat line. In our case, we take that sine wave and we just put it over here. And then there's this other wave in the machine itself that is being dealt with, in that these combined waves are affecting the machine in such a way that every time it tries to vibrate, it gets shut down, so to speak. It's like Scott Evil, basically. It's like every time the machine.
Right. Yes, I got you. So with Clipper, they're doing that using an accelerometer, and they run a series of tuning and then read back what they're getting from the accelerometer. So as of right now, is there like a menu option to get that information in Marlin?
Yeah, in Marlin, what you put in is just the resonance of your machine. If you know it vibrates at 20 hertz, you put that and then it takes care of it. But but you can tune that. And basically what we have is, our approach is, since we don't have a place on every possible board where you could just attach an accelerometer, we just have you print the model that is used for testing resonance. So it's it's an L shape with some divots in it.
Right.
And you can easily see that it's ringing in the surface. And we just run this, and then at each layer we change the resonance period that we're compensating for. So initially it'll start out looking really bad.
Right.
And then it'll get somewhere up towards the middle, it'll start to look really good and smooth. And then as it gets up towards the top, it'll start getting more ringing again. And so if you know that you run this test print from like 1 millisecond up to 20 milliseconds vibration, and it looks great in the middle, then you know that 10 milliseconds is a good starting point to get to compensate. And then if it, then you can tune a little bit around it to get it.
So it's very similar to the linear advance approach, which is let's print a test print from this range to this range.
Yep.
You tell me what looks good, and then we'll target that as our solution to the problem.
Yep, and you can do that with Clipper too as well. I mean, they include in their manual an object or two that you can grab. And
so if you don't have an accelerometer with Clipper, they have that as the alternative.
Yeah, or just as your test piece to see how well you tuned it. You can use that because it's meant to incite as much vibration as possible, and maybe not as much, but not in a typical print. The cool thing is, like with typical input shaping, you'll get these rounded corners, and it tends to soften the surface of your print a little bit and round out corners. I'm not sure that we'll get exactly the same with our approach. There's definitely going to be some change of there's going to be a change of the way that corners go, but because we combine it with it doesn't matter whether you're using junction deviation or jerk or even X curve acceleration. All these things can be tuned as well around.
That was actually my next question: is how are all of these? So you've got linear advance turned on, you've got S curve turned on, you've got you're still setting your jerk and acceleration settings. How does all of that work together now? And do you still turn everything on and hope that gives you the best solution?
Yeah, well, that's the thing, is all of those target different aspects. Like your junction deviation or your jerk is looking at direction changes and how quickly they can be done, and without causing mayhem, lost steps and things like that, or whatever. Get within the physical abilities of your machine. And also get the best.
It sounds like testing might change then a little bit, because rather than using acceleration and jerk or junction deviation or whatever to compensate for ringing, now we're kind of looking at physical limitations of the machine, not stop giving me ringing.
Yeah, and you kind of just go, well, okay, if this is, and the thing is, you move it to a different table, you might have to.
I was already thinking about that. If you move your printer, tuning now has to kind of, or at least the resonance tuning will have to change.
Yeah, to some extent, maybe. At least certainly the amplitude or how quickly it dissipates might change. Mm-hmm. We don't actually worry about that, which is interesting. Like we just can't. We try to do 100% cancellation on every step that happens, and each step has a certain amount of.
I'm amazed that you can do that at speed. I'm amazed that you can still print extremely quickly while compensating the entire time.
Yeah, it's again, it's surprising. And we have the underlying algorithm of all motion and other things. Basically, anytime you need to draw a line in computer world, you use the Bresenham algorithm, which it's a discrete. It takes something which is discrete and which is rational, and creates something which is as close to smooth and continuous as it can.
Right.
And from that, there are flaws, obviously. Anytime you use it, a pixel has dimension. It's not a perfect point. It's not dimensionless. And we don't have infinitesimals to work with and, things like that. So we have to...
There's a smallest unit for everything in reality. In our case, it may be the size of your microstepping.
Yeah, and, the interesting thing about steppers, too, is as you spin them, there is a tiny microscopic bit of overshoot in those steps. It doesn't lock in
Particularly
perfectly.
as you get into your micro steps rather than your real steps.
Yeah, and the magnetic field resists the tendency to oscillate, but there's still microscopic oscillations in there.
Sure.
And so you could think, if you really wanted to target everything, you could even, and maybe in the future you'll have zillion, megahertz processors that can deal with everything physical in the system. But yeah, you could even look at those and start to target that stuff. There are apparently stepper drivers out that have a input shaper on the board itself.
I saw that link that you posted on Twitter, and I actually took a look at that. But it seemed to have its own level of setup and configuration that you had to go through in order to get that working.
That one's fascinating to me because it has, again, it's blind. It doesn't know. It doesn't see your G code. All it sees is you sent it a step, and you sent it 20 steps or whatever, and it has to deal with figuring out how to maybe rearrange those steps or retime those steps. So it's not doing exactly what you told it, but it's fixing it up for you.
Right.
But I mean, trinamic steppers are already doing that with the interpolation of 16 extra steps for every step, and so yeah, there's
and you can buffer. I mean, from a time perspective, you can buffer a certain amount of commands without having any detrimental effect. It just means that your steps may be a tenth of a second behind or a half a second behind, but that's not really making a difference because they'll catch up.
Yeah, actually, and as long as everything is synced up and it doesn't get fall too far behind, you're fine.
Right.
That's the thing. If there's like a continuous always a half second delay or something, that's fine. But if the thing was taking extra long or delaying or stopping you had to wait for it, that would suck. So yeah, it's a fascinating problem, and I really was I was at quite a loss to start to solve it. I was starting to look at the rep firmware code, and my head was swimming. I was looking at a little at the Clipper code, and again, not quite grokking it all. I did have a chance to talk to Kevin O'Connor at Earth, who is the creator of Clipper, a little bit about their approach to the whole problem, and a lot of it is just over my head. I've been going back and signing up for Brilliant, and I'm studying calculus. So
I was about to say, I mean, what we're dealing with is a physics problem. I mean, it turns into a software problem, but the software problem is secondary to understanding the physics of the problem.
It's kind of why I got into this whole robotics thing. I was like, well, on the desktop or in games or whatever, your whole world is under your control.
Mm-hmm.
You have complete, if something goes wrong, it's your fault. It's a bug in your program or whatever. With a machine like this, it's like there's so many unpredictable things that could happen. A step could get lost and you would never know. And all kinds of other things can occur. Of course, the vibration being certainly a major issue that we've wanted to get. Previously it would just say go slower, but now we have the option to really deal with it, and we have boards that are fast enough and even have their own floating point units and stuff. So of course, all the stuff we're doing is in most of it is integer math too as well. So
when we're talking about input shaping, I'm assuming you don't have input shaping on the 8-bit boards.
Yeah, it works on the 8-bit boards.
Does it really?
Yeah, it's not very processor intensive.
A bad assumption on my part. It's not even necessary to have a super high speed 32-bit board.
Nope. As long as you have a board that has enough free RAM, so you may have to turn off a feature or two if you want it, because right now it's using a big old buffer to basically remember what time this step happened. And then keep a little buffer of, say, 10 milliseconds worth of steps, so it can repeat those 10 milliseconds worth of steps later. And it's a big old queue, a circular queue. But basically, if you have, you can do different things. Like you can set it up to be, you can try and tune it so you have a smaller buffer and get it to fit. But yeah, so there are some AVR boards that have 16K of RAM on them.
Oh yeah.
Even though they're smaller. I think one of them is like the 628p or something like that. One of those. Strangely enough, Melzi. It's one of the Melzis, basically. Has 16K of RAM, so it's yes, you can actually put it on an 8-bit board.
You can build everything in, and it still fits.
Yeah, so that's kind of the myth. Is you didn't have to have a Raspberry Pi just to have input shaping.
Right. Yeah. And I think that's important to let people know that That wasn't a bottleneck.
Yeah.
It just didn't exist in this code base, and they put it in this code base.
Let's see, about input shaping, I'm just excited for it, really. I can't wait to put it on all my machines. And,
So right now, is input shaping in the 2.1.x tree ready to test?
It's in the bug fix branch,
okay.
Or it should say there's a pull request pending. It hasn't been merged yet. It's working great. The tests I've seen look awesome. I don't know if anyone's done like a massive test, like with all kinds of edge cases yet, to really push it. But that's what's going to happen next. The part I want to do.
Have you seen any channel actually do any YouTube channel do any tests on it?
Well, it's still not being merged. It's probably, I wouldn't expect Chris to like jump into it right away. But once it's in there, and I am going to include and mark it as experimental in 2.1.2, which is coming out in a few days. I just have to go through the changes that have been pushed so far and clean them up and make the release notes and all that. So that'll be out soon, and then people can try it out and let us know. We'll find all the bugs and fix it up. This is a very, very basic. Like, there's different types of input shaping that can be more fancy and deal with more resonances and stuff. I don't know if we'll need it, but we'll see. I mean, it's so effective that I don't know. I mean, it's kind of, I don't know how closely it fits how others do it. I think it's very close to how others do it, but it just seems weirdly and it just seems weird to me because it is on that like every step level.
Right.
It seems like, could they really be doing it that way? I don't know, but I'll study and see. And actually, I'm talking to David Crocker also on. I've got him on Slack over here, part of our Prusa collaboration, and I'm sure we'll be gabbing about it more. But I just told him how ours works, and he'll tell me whether. I'm sure he'll tell me whether it's similar to what he's doing already or not.
So that's it for this part of the interview. I want to go ahead and let you know what's coming up in the next part, but real quick, one more time, thank you to GreenGate 3D for sponsoring this video series. They've got over 30 different colors of PETG. I've got my favorite 4 colors here. Fantastic. I use them all over the shop here, functional prints, models, whatever. It's just a fantastic filament. Prints on almost any printer because it prints on an 85, 90 degree bed, and it needs usually under 245 degrees Celsius on the nozzle, which works on just about every printer. Now in the next part of the interview, I'm going to have everything from adaptive step smoothing, square wave stepping, Marlin stability, upgrading, configuring, compiling, what is coming up in Marlin 2.1.2, which is going to be the next release of Marlin, and we're going to be talking about Scott's hope for Marlin. All of that and more in the next part of this interview. Stay tuned. Make sure you're subscribed. As usual, I'm Chris. This is Kersey Fabrications, and I will see you next time. Thanks for watching.